Let's start taking a look here. So I warned you ahead of time, you had to use the t-score for this. Hopefully you saw why. Sometimes it's a little hidden, but let's see what happens. So what is the claim? Our mean for our new drug is less than what? 11.2. So make sure the sample numbers should never show up in the first step. Where does that go? Yeah, the high. Because it doesn't have an equal sign. What's the ho going to be? This is a one-tail or a two-tail. This is going to be a one-tail test, right? Just down there. Just one side will show evidence less than. I already told you t-scores. Why? Yeah, sigma unknown. What tells me I could do anything? Normal, because of. Yeah. Now, if the sample size would have been 22 in this problem, what does that mean? I have to say somewhere. If the sample size is 22, does the sample size make it normal enough? No. I have to state somewhere that it's normal. The population is normal. And then the sample size doesn't matter. So it's when the population is not given to me that it's normal, I need the sample size to save its x. I need n to be greater than 30. So in this case, that's true, but I have to use t-scores because I don't know sigma. I only know s. Now, does everybody see how to see that? The new drug is given to 45 stat students. They get relief, and that came from the sample, and this came from the sample. What I always get is somebody says, but we know standard deviation, Jeff. Why don't you use t-scores? That doesn't make sense. What differentiates is which standard deviation do you know? You always have to know some standard deviation, but which one do you know? Sample in this case. I like it. My poor phone's about to die. So if I want to define the rejection region, 0.025, what's the degrees of freedom? 44. I can't remember. Is that on there? No. So what am I going to use? I don't know why I was so mean. You could actually use one of two things, to be honest. You could use 40 or 45. Technically, you should use 40 just to make things harder on you since there's something we're not sure about. So if I use 40, alpha is 0.025. I've got a one tail. So one tail, 0.025. Stop at 40. I get 2.021. If you use 2.014, that's okay. I think I told you that I just put a little note, but I would be okay with it since it's so close. But we should use 2.021. Now, if I put this here, what's wrong with that? Some of you guys like what you just said, dude. But when I put it on the picture, I better make it make physical sense. It should be negative. We're the humans. We have to put the negatives on the right place, so they didn't have to make a bigger chart than they did. So now, here's where, all right, I'm going to forget to say T star. I'm just going to say Z star all the time. When I calculate a t-score versus a z-score, they both measure the exact same damn thing. So that's why I kind of forget to say t instead of z. But yeah, you could say if you're going to calculate a t-star, what do you do? Why? Because I'm using t-scores. If t-star is what? Then we can reject the null. When? T-star is less than negative 2021. Now just to really hammer this point home, if I would have been able to use z-scores, the z-score I would have used would have been 1.96. Since there is something in here I'm not as sure about, I should make it harder for me to find evidence. That's why a t-score makes sense. 2.021 is bigger than 1.96. It's further away. It's harder to pass that test. We should always penalize ourselves for not knowing something for sure. Doesn't mean you have to like hit yourself or something. Just this. What do I know from the sample? X bar was what? Phone is still going. 10.4. Barely hanging on. 10.4. S is, and here's the next thing that people don't appreciate, but I really try to make this a big point. I still have to do this. Of course I do. Because I need something that works for groups of size 45. And S, I know it's a sample standard deviation, but it's still for individuals. I always have to do this when I take a sample and ask about sample means.